In lesson 12, we're going to look at the pharmaceutical industry. Before we do that, we want to review elasticity. You do that by clicking on this plus and watching this video. After watching the video, answer the following questions. After watching the video, we can apply what we learned in the following lesson. In Rise of the Planet of the Apes, genetic scientist Will Rodman, played by James Franco, conducts research at Genesis to develop a cure for Alzheimer's disease, a condition affecting his father. After creating ALZ-112 and later ALZ-113, he tests them on lab chimpanzees. While ALZ-13 becomes infamous as the simian flu for killing humans and boosting ape intelligence, this scenario occurs later in the story. Suppose that before these events, Genesis holds a patent on ALZ-106, a modestly effective treatment for Alzheimer's disease. ALZ-106 is considered modestly effective because it only slows the progression of the disease. Given that the research development, FDA approval, and patent cost for ALZ-106 are sunk, and there is no practical limit to the number of pills that can be produced relative to the patient population, production capacity is essentially unconstrained. While the total fixed cost, research, development, and approval amount to $198.694 billion, the marginal cost of producing an additional ALZ-106 pill is negligible, effectively zero. Genesis has hired you as a consultant to estimate the demand for ALZ-106 pill, which you have successfully completed based on the demand data provided and graphed below. Your task is to recommend an optimal price point for the product. This axis here, the y-axis, is the price axis, where these are dollars per pill. The gray curve is the revenue curve. The Y scale is in billions of dollars. So when you're reading this gray curve, this peak here happens at around $225 billion. At that same quantity, that gives us $225 billion. The price is about $160 per pill. So you can think of this as the revenue axis, but you have to multiply it by billions. And it's actually the price axis in dollars per pill. I've already opened up Desmos here. I'm going to copy this equation to Desmos. I'm not going to include the D. I'm going to change the color of it to black. I got to fit it in this space here. Notice that the y-axis goes from 0 to about 1,000. I'm going to click the wrench here and type 1,000 in for the highest range for y. And then the x-axis, it runs from 0 to about 3,500. Then I can set the demand equation in here. I can fine tune it. I'll be using this equation to first calculate the prices per pill along the demand curve using these quantities. Now, quantity is along the x-axis. And so when x is 1,070, quantity is actually equal to 1,070 million or 1.07 billion. Because again, quantity is in millions of pills. I'm going to format this line here so that it's black, it's dashed, and has a thickness of 1. I want this dashed line to go to a height that just touches the demand curve, and its minimum value is 0. In order to do that, I'm going to put in a lot of spaces.
Press and hold the Shift and squiggly bracket keys.
I'm going to type 0. I'm going to hold down the Shift button to get the less than symbol. Then I'm going to press the equal sign to get less than or equal to. Then I'm going to type Y. Y is the height. Notice when I do that, what happens? The dashed line stops at a height of 0. Now what I want to do is I'm going to press Shift and hold down the less than symbol on the keyboard. And then I'm going to type equal, the equal key. Then I'm going to type the price. The price is about 200. Now it's not exactly 200. I can zoom that in and see that 200 is too much, right? I want the price to be 197. If I type 197 here, it looks like everything's fine. The dashed line just touches the demand curve at 197. But if I change this value to 1100, what happens is it overshoots, right? So one way to fix that is I'm going to copy this part of the demand equation, and I'm going to replace the 197 with it. I'm going to replace the Q with the letter X. what happens is the dashed line stops at the demand curve. It doesn't matter what the value of X is, because X is a defined value, 1,000. That's the first thing I want to do. I'm going to zoom this back out. Now I can cover up this stuff here by adding spaces and then bring this back down here. Okay, so what is the price when the quantity is 1,070? The price is 197. Let's add 197 here. Now we need to calculate the price when the quantity is 1,220 million pills.
$182 a pill.
The quantity is 1,370. Price is 167. The quantity is 1,520. The price is 152. When the quantity is 1,670 million pounds, the price is 137. When the quantity is 1,820 million pills, the price is 122. When the quantity is 1,970 million pills, the price is 107. And notice that as the quantity goes up, price per pill is going down. That's the downward slope of the demand curve. I'm going to have you calculate the elasticity using this equation. The slope is the change in the price over the change in the quantity. When the price falls about 300, quantity increases by just over 3,000. Another way to calculate that is to take the difference in these two prices divided by the difference in those quantities. So when the price is 182, the quantity is 1220. When the price is 197, the quantity is 1,070. So this is the change in price. That's the change in quantity. But we have an issue here. The quantities are actually in millions. We need to multiply this by 1 million. And we need to multiply this by 1 million. Decimals will give you the number in scientific notation. This scientific notation, written as a decimal, is just negative 0.6 zeros between the decimal and the 1. 1, 2, 3, 4, 5, 6, and a 1. Because what this says is move the decimal place 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. Negative 1 times 10 to the minus 7. So these two numbers are identical. In the expression, it says 1 over the slope. 1 over the slope would just mean we're going to invert this fraction. I'm going to move the thing in the denominator to the numerator, and I'm going to move the numerator to the denominator. So now this part here, 1 divided by the slope, is actually this value. Then I have to multiply that by the price-quantity ratio. At 197, the quantity equal to 1,070. But it's not 1,070, is it? It's multiplied by 1 million. The elasticity is a negative 1.84. I'm going to type that right here, negative 1.84. But notice what I can do here. I can factor out 1 million in this difference. And what happens? I get the same exact number, negative 1.84. Now I have 1 million here, and I have 1 million here. 1 million divided by 1 million is 1. So I factored 1 million out of the numerator here, and I canceled it with 1 million that was multiplied by this. My elasticity is still negative 1.84. There's a shorter way to do this. I can take 1 divided by the slope of my demand equation. The slope of my demand equation is negative 0.1. And then I can just multiply it by the price quantity ratio of 197 and 1,070. Get the same value, negative 1.84. So I'm going to delete these rows here. I'm going to use this to calculate the rest of the elasticities for the remaining quantities. At the same time, I'm going to calculate the revenue. And the revenue is 197 price per pill. We're going to multiply that by the quantity, which is 1,070. But it's not really 1,070. It's 1,070 times 1 million, because 1,070 is in millions. But then I want to report revenue in billions of dollars. So I'm going to divide this whole thing by 1 billion. Okay, so now the revenue is in billions of dollars, $210.79 billion. Now I'm going to simplify this expression. I'm going to put a times and a 1 here. Notice the value has not changed. 1,000 million is a billion. This is 1 million, and this is 1 million. 1 million divided by a million is 1. So these two numbers cancel each other. And notice that my revenue is still $210.79 billion. Let me close this down, hide some of the details. Let me reset this to 1,070. At 1,070, my price is 197, 197 and 1,070. My elasticity is a negative 1.84, 197 and 1,070. And my revenue is $210.79 billion. Now I'm going to copy this value, and wherever I see 1,070, I'm going to replace that
with
1,220. And then the price is 182. So wherever I see 197, I'm going to change that to 182. And now I get a revenue equal to $222.04 billion. And I get an elasticity equal to negative 1.49. Now I'm going to change quantity to 1370. The price is 167. Wherever I see 1220, I replace it with the quantity 1370. I'm going to replace the price with 167. Now my revenue is $228.79 billion. My elasticity is negative 1.22 because this 8 makes that a 2 when we round to 2 decimal places. I got a quantity of 1520. So wherever I see 1370, I'm going to replace it with 1520. The price is 152. So wherever I see 167, I'm going to type 152. I get a revenue of $231.04 billion, and I get an elasticity of negative 1.00. I'm going to copy the quantity 1670, which is in millions of pills, place 1520 with it. And then the price should be 137. It is. I'm going to replace 152 with 137. 152 with 137. My revenue is $228.79 billion. Notice it's the same value as what we have here. That's because the graph of revenue is a parabola when demand is linear, and it's symmetric about the vertex. This is the mirror image of this side. So it looks like the peak was at 1520. When the quantity is 1520, right about here, we grow straight up, we get to the peak of revenue. So this value is going to be identical to that value. The elasticity is a negative 0.82. Now the quantity is 1820 million pills. Wherever I see 1670, I'm going to replace that with 1820. And then the price should be 122, which it is. So I'm going to replace 137 with 122. I get a revenue equal to $222.04 billion, which is the same as that value. Again, that's because of symmetry.
the elasticity is a negative 0.67.
Now, when the quantity is 1970, I'm going to replace 1820 with 1970. The price should be 107, and it is. I'm going to replace 122 with 107. The revenue is $210.79 billion, which is identical to that, again, because of symmetry. The elasticity is a negative 0.54. So if you look at revenue is rising, it peaks when the quantity is 1,520 million pills, and then revenue falls. Meanwhile, the price falls linear as we move down the demand curve and quantity is increased. So revenue is maximized, it looks like, when the elasticity is -1. With Genesis having a monopoly in the treatment of Alzheimer's disease, the marginal revenue curve
Or Monopoly has the same
intercept as demand, but its slope is twice as big as
linear demand.
0.1 times 2 is 0.2. Now, when I press enter, my math will draw the marginal revenue curve in our graph above. This is the revenue equation. Its slope starts out really steep here. As we move up the revenue curve, the slope of this curve is getting closer and closer and closer to zero. When the revenue curve is flat, if you look right here, flat line has zero slope. And then all of a sudden the slope is negative. It's at its most negative value there. Marginal revenue is the value of the slope at each
Quantity.
So at a quantity of zero, the slope of revenue is at its highest value. The curve is steepest here. As quantity increases, the marginal revenue curve, the height of it, decreases because the slope of the revenue curve is getting closer and closer and closer to zero. Here it reaches zero. The marginal revenue curve reaches zero at this quantity, which is 1520. At 1520, marginal revenue is zero. If I plug 1520 into that value there, 304 minus 0.2 times 1520, we get a marginal revenue equal to zero. Whenever you hear the word marginal something in economics, the marginal means slope up, slope of revenue, marginal revenue. Slope of revenue is zero at 1520. And that's what we observe up here. This has zero slope. Remember what we said about the marginal cost up here initially. It's negligible. When the company produces a million pill, costs are $198.694. If it produces a millionth and one pill, the cost is still $198.694 billion. Increasing from the millionth to the millionth and one pill does not change the cost of production. So marginal costs are zero here. So the marginal cost is a flat line at a height of zero. And when I press enter, you're going to see a green flat line at height zero. Marginal cost is right here. The green line has a height of zero. Notice marginal cost and marginal revenue intersect at 1520. Profits, if you remember, are maximized when marginal revenue equals marginal cost. So Genesis maximizes a profit at a quantity where marginal cost intersects marginal revenue, which is 1520 million pills. At that quantity, price per pill is 152. At this quantity, 1520, and a price of 152, which is right there, revenue is maximized. If we raise the price, revenue falls. If we lower the price from this peak, revenue falls. So we can't get any higher revenue. We can't extract any more out of this market, so we think. The firm's revenues are going to be equal to the total amount of money consumers spend on this drug. At $152, at a quantity of 1,520 million pills, consumer expenditures on the company's drug has been maximized. Its revenues have been maximized. And because marginal cost equals marginal revenue, the firm's profits have been maximized. We have to find the correct letter down here for the scenario. Profit, revenue, and total consumer spending are maximized. So my letter is C. Now, notice what happens when I press enter here. The dashed line is just to the right of 1500, so this is 1520. It goes up to the demand curve and then goes left toward the price, the monopolist price. And that monopolist price is 152. Based on the analysis, you recommend that Genesis set its price equal to the computed price above. Its supply curve automatically becomes a flat line at a price of 152. When I pressed enter, it erased everything but the demand curve and a perfectly elastic supply curve. And this perfectly elastic supply curve crosses demand at the price 152 and at a quantity of 1,520.
This point.
Without insurance, 1,520 million pills will be prescribed at a price per pill of $152. Now, the interesting thing is, this is the scenario where there's no insurance, but we're going to introduce insurance with a copay of 40%. Now, if everyone has insurance with a 40% copay, and price transparency is not required, Genesis knows that consumers are willing to pay at most $152 a pill. They know that. That's why they hired you for 1,520
million pills prescribed.
It also knows that insurance companies are obligated to pay the remaining 60%. A billed price is the price that Gensys or other pharmaceutical companies
Billed to the pharmacy. The consumer pays 40% to the pharmacy. The insurance company pays 60% to the pharmacy. And then the pharmacy pays the drug company.
Now, to get the bill price, you divide what the patients are willing to pay by the 40% copay. So patients are paying $152 per pill.
Divide that by the coinsurance rate, in my case, 40%, or 0.40.
So the bill price is $380. On net, insurance companies pay 60% of that. So 380 times 0.60 is the portion paid by the insurance company. The patients pay their pharmacies 40%, and 40% of the billed price is 152. At 152 is not a coincidence because we take the 152 and we divide it by the 40% copay. Notice what happens when we enter those numbers.
Got steeper as it rotated clockwise.
At this quantity, which is 1,520 million pills, the consumer is willing to pay at most 152.
But because the pharmaceutical company knows that,
And knows that insurance companies are obligated to pay
60% of
the billed price, it can set the billed price at 152 divided by the coinsurance rate. The copay causes ALZ 106 demand to rotate outward and clockwise. This is the resulting equation. The way you get the equation is, let me just show you real quick. The intercept of demand is 304. We're going to divide that by 0.40. That's where the 760 comes from. We're going to do the same thing to the slope. The slope of the demand curve is 0.1. We're going to divide the slope of the demand curve by 0.4. So the coinsurance makes the intercept larger and it makes the slope larger. That's what causes it to rotate. I'm going to delete these values. I copied in the new demand equation. I need to change the color of it to match my map, purple. I'm also going to draw in the supply curve. To graph the supply curve, we got to remember that price is the y-axis. So we're going to type lowercase y equal to the monopoly price, 152, the price that consumers are willing to pay. I'm going to reset the quantity here, 1520, and then I need to change the color of this to red. I'm going to go up here to line 2. I'm going to expand this out here. I'm going to change the 304 to 760, the intercept of our new demand curve. And I'm going to change the 0.1, 0.25, the slope of our
new demand curve.
And then I'll squeeze this back down. Without a third-party payer, 1,520 million pills would have been prescribed at a price of 152. But because of coinsurance and how it works in our economic model, the pharmaceutical company knows 40% of 380 is this 152, which is the most the consumer is willing to pay for this medication. So the difference between this dot's height and this dot's height is the portion of the billable price that is paid by the insurance company. And the difference between this height and zero height is the maximum price consumers are willing to pay for 1,520 million pills. Given the 40% copay, why does Gensys bill $380 per pill instead of 152? Well, to understand that, let's calculate what its revenue is when the quantity is 1,520 million pills times the price of $380. So $380 again comes from this new demand curve, the rotated demand curve. We're going to multiply that by 1520, the quantity in millions of dollars. Now, this isn't the revenue. Again, this is in millions of dollars. We're going to multiply that by 1 million. We're going to report it in billions of dollars. So we're going to divide this whole thing by 1 billion. There's 1,000, million, and billion. So in billions of dollars, Gensys's revenue is $577.6 billion at the billed price. If it bills the insurance company at 152, it'll sell more pills, 2,432 million pills. We got to change this to 2,432. So if it bills insurance companies 152, 40% of that is paid by the consumer. The price they pay out of pocket is $680, that value right there. The quantity again is 2,432 million pills, what is revenue for this company? Well, if they're building out at 152 and the quantity is 2,432 million pills, its revenue would only be $169.664 billion. So building at the lower rate decreases Gensys's revenue by how many billions of dollars? Well, this is what its revenue is at the lower price. We're going to subtract that from its revenue at the higher price. So building at the lower price decreases Gensys's revenue by $207.936 billion. What does Gensys do with the extra money it earns from building at the higher price? In order to figure out that answer, you're going to read these linked articles and then fill in the blanks.